Hello, we are a web-based visualization of real-time sensor data group. My name is Sheetal.
Hi everyone, I am Fatih.
I'm Ben.
And I'm Andrew.
Our client is Dr. Quamrul Huda from Government of Alberta. To introduce our project, our problem that we are trying to solve is to address the need for a researcher to have access to air quality information at a remote location. So these are the places anywhere around Alberta or rural places around Edmonton to have access to their air quality information. Our mission has been to create a system to both measure and report this critical data to a large audience. Our expectation of the project is to involve hardware and software developments for prototyping a system that will have microcontroller-based data acquisition and a web-based real-time visualization. An Arduino is used for acquisition of sensor data and onboarding logging. The data will then be directly transmitted to a web page every minute. The web portal will receive data packets consisting of multiple parameters and display them on a graphical user interface. Finally, the outcome of this project. Over the past 3 months, we were able to build a design and prototype an air quality sensor board to be deployed at various locations throughout Alberta, where it will constantly record and report various metrics to our data analysis platform through cellular connectivity and allowing real-time interaction with the sensor readings. We will now jump into our demonstration.
So here we have a map. Currently we don't have any devices here, but once we add devices, we will be able to see the devices on the map. Each device measures air data, and then users will be able to browse through these devices on this map. We will start by adding a device and then demo the whole process.
So first we'll need to log in with an administrator's password. We'll just do that now. And as you can see, you're brought to the devices page. So from here, you're able to add new devices that you place out into the field. You're able to do other things like add users, view system settings, and adjust other settings. So right now we're going to add a device with the IMEI, which is a unique number that comes from one of the hardware components on the board. So that identifies the device, and then you specify the latitude. And these are all just, I copied them ahead of time. Makes it a little easier, but it's a device that Andrew has set up at his house. So we'll just say, as the memo, we'll say Andrew's house. And then you can go ahead and create the device. So it's now added. That auto update, you can see it right here, the new device in the device list.
Now that Ben has successfully added this device, we're going to start things up on this hardware side over here. We have over here a humidity and temperature sensor. We have an LED light to just ensure our analog sensor is working. We have the PM sensor over here. And this blinking thing right here is our SIM 7000 LTE shield. If you see closely, here's the IMEI number, which Ben used earlier to register this device into our website. Our program has a 10-second interval, which it uploads the data to our server. So if you wait for it, yeah, so it's sending data right now. It's just getting all the data, just all those data over here, and it's sending it to our server. And as we see, we're getting a 200 back, which means that data registration has been successful.
All right, so if we just click on the station that's recording data at Andrew's house, we can see the station analyzer pop up. And it's a tool that you're able to use to look at all the different data being measured at a given station. So if you can set the date range for the date range of data you want to look at. You can add different parameters. So things like temperature you can add, and then you see it plotted up above, or relative humidity. You can see there. If you want a little explanation of the data, you can hover over top of the pill badge there. So we're going to have Andrew now start heating the sensor with an air blow dryer or a hair dryer. And that way we'll be able to see the effects of the temperature going up here. just to demonstrate for you guys the live nature of the data. So I just have to hit refresh real quick because it's, as live as it is, it's not that live. And as you can see here, so we're just starting to see an increase from his base of 19.1 up to 19.9. I'll refresh once more and add temperature. It's a much bigger spike. And you can see the humidity is being affected as well as air is being blown away and it's being heated up. We'll just give it one more. There we go, big spike there. And there you have it. And then, so just to demonstrate some of the other features of the application, we'll log back in after refreshing like that. By going into settings, we've actually added something called demo mode. Now, from speaking with our client, we realized pretty soon that a really important aspect of the app for him is being able to demonstrate it to some of his coworkers. And being a government application, in order to get funding and whatnot, it's very helpful to be able to demonstrate these to potential sources of funding. So we added something called demo mode, where you can click it to enter demo mode and return to the map. And what you see now are a ton of simulated stations. So this gives more, like, it's all simulated data, but it gives a more realistic look of how this would appear once all the stations were properly deployed. So now if you click on a station, you can look at all the parameters that he intends to record with this sort of thing. So, SO2, for example, can be looked at here, again, with the brief description, NO2, all the planned metrics that we were hoping to collect. You can see the battery of a given station. If you change to a new station, the data changes with it. And then finally on the top here, we have this map level filter where you can switch. Right now it's showing wind. And on this spectrum here, from 0 to 150 kilometers per hour, you can look at particulate matter of size 2.5, and it kind of gives you an idea of the spread throughout Alberta. All right, so one final feature of the station analyzer here. If you're a researcher or just somebody who wants to do some further analysis on the data gathered at a given station, you can select the station, go to the station analyzer, add whatever parameters you're interested in, for instance, particulate matter 2.5 and SO2. And then you can click download data, and that will actually download a CSV file that you can then open in Excel or whatever software you hope to analyze it in. And your selected parameters will be included here along with some station information and the timestamp. So that can be helpful for researchers and whatnot.
So far, we were able to complete many of the requirements of the project. The working things are the devices can send data to the server side successfully, and then it can all be saved in the database. The login and the device controls are working. You can add devices and users as an admin. They are all in the dashboard. The data communication between the hardware and the software is also working. The things we haven't implemented yet, we have not implemented HTTPS, so the project still needs to take some security measures.
For future work, a lot more sensors could be integrated into the Arduino. Currently, it's only the temperature and humidity sensor and the PM sensor right now, but later on, we could add things like NO2 sensor, wind sensor, SO2 sensors, and much more. To conclude, over the past 3 months, we were able to create a working prototype of the desired system with the guidance and support of our client. Although it serves as a working proof of concept, much work will still be required before it can be implemented as a working system. Firstly, the hardware will need to be organized into a custom PCB and prepared in a casing for field deployment. Secondly, the analysis platform cloud infrastructure will need to be scaled up to increase its request capacity to match an increase in user demand, as well as have several new features added. Thank you very much. and we will now take questions.